All right, everyone, welcome back to another Algebra 2 video. Mr. Beseda here, coming to you with a new method for solving quadratic equations. So in the last couple weeks, we spent a lot of time doing questions that look like this first one on the left. As you can see over there in that equation, x squared plus 10x minus 24, I've went ahead and factored that one. I already did my check. And then I would use my zero product property to split these two factors up. Setting both of those equal to 0. And then both of those are pretty easy solves. I would subtract 12 on both sides for my first one. And then my second one, I would add 2 on both sides. And I would get x equals negative 12 and x equals 2. Now, if I look at that second equation, x squared minus 13 equals 0, what I immediately notice is that I'm missing my x term in the middle. And in our last class of last week, we talked about how if we were trying to do this with factoring, our check would be 0. We try to pick numbers that multiply to give me 13 and give me a check of 0. But no matter what we tried on this one, it wouldn't really work that well. Because I would have to pick 1 and 13. And there's no way that 1 and 13 would complete the check to give me 0. So if that doesn't work, the question becomes, what does that leave us with? And that's going to get us set up for our second method for solving quadratics, which is the square root method. So at the top here, I've put that our first method for solving quadratic equations was our factoring and zero product property. The problem is that doesn't always work. So our second method that we sometimes use is called the square root method. Now, we're going to present this as a new method, but it's something you've actually done before. We're just adding a little bit to it in this video. So the first thing you should know is that we only use the square root method when we only have, and this is important, x squared terms and constants. And what that means is that we should not be using the square root method when we have the regular x terms in the middle. So our general steps for running the square root method are as follows. And this is why, say you've done this before, back in our very first unit, we solved with inverse operations. And that's basically what we're doing here. Our goal is to get the x squared by itself, and then take a square root to solve. Those are your steps there on the right. In this problem, 4x squared minus 20 equals 16. My goal is to get that x squared by itself. X squared is on the left side of the equation, so everything else on that left-hand side of the equal sign needs to get moved over to the right. In this case, I'll start by adding 20 to both sides, giving me 36. I still don't want to take the square root yet, due to the fact that there's still a 4 over there. I will then divide both sides by 4. That gives me x squared equals 9. And once the x squared is by itself, now I can go ahead and take a square root. And one thing that we're going to add that we didn't do before, when we solve these equations, most of you would probably say the solution is x equals 3, but the solution could also be x equals negative 3. And, well, why is that? Well, if you think about it, negative 3, if I square it, would also become positive. So when we solve these quadratic equations with the square root method, we do end up having two solutions, normally both the positive and the negative version of the square root. Now let's take a look at a couple more. The first one up here, a squared plus 9 equals 13. Very straightforward. Again, the goal is getting the x squared, or in this case, the a squared term by itself. So I would start on this one by subtracting 9. That gives me 4. Now I can go ahead and take a square root on both sides, since the a squared is by itself. You would say that a equals 2, but your second solution would be that a could equal negative 2. Again, because negative 2 squared is also 4. In our next example, we see something a little bit different because we have an a squared term on each side of the equation. We've got a 5a squared on the left and a 3a squared on the right. That is not a big deal at all. I recommend putting that line down the equal sign and just getting your a squared terms on the same side. For me, I usually bring my a squared terms to the left. As you can see, I moved my 3a squared over to the left. 5 minus 3 gives me 2. So I bring this down as 2a squared plus 10 equals 42. And now it looks like the first equation we did. It's just a matter of getting the a squared by itself. The next step would be subtracting 10. Can you think of what would happen next? If you're thinking to divide by 2, you'd be correct. Remember, we don't want to take a square root until the only thing there is just that variable being squared. At this stage, with a squared equals 16, we can go ahead and take a square root. And the square root of 16 is 4, or negative 4. And we do include both answers there. Now, if you're thinking this looks familiar, you're correct. We have done problems like this before, like I said, back in Unit 1. But what I want to add today are sometimes we have square root method problems where things don't work out so cleanly. You probably know that you can't take a clean square root of every number. Sometimes it doesn't work. So we're going to see what happens in that situation. So our next example, we've got a squared plus 9 equals 19. Now, if my goal is to get a squared by itself, the first step you would probably say, and you would be correct, is to subtract 9. We're trying to get a squared all by itself. But at this stage, a squared is by itself. I will take a square root. But if you're wondering about the square root of 10, you're wondering for good reason, because the square root of 10 is not a clean answer. So in that situation, what do? Well, there's two things. Sometimes I want the exact answer, and sometimes I want an approximate answer. Okay. So when I say an exact answer, what that means is you are just going to leave that answer as is, and you're going to tell me that a is the square root of 10, or a is the negative square root of 10. You're not going to give me a decimal, you're just going to leave it as the square root of 10. We don't know what the square root of 10 is, but whatever it happens to be, that's the correct answer. And that's called exact. And if I instead ask you for the approximate solution, that's when you go to your graphing calculator or scientific calculator and actually find out what the square root of 10 is. The square root of 10 is approximately 3.16. So in that situation, you would give me a equals 3.16. Or a is negative 3.16. Okay. Sometimes I'll ask you for both. Sometimes I'll ask you for one or the other. Either way, this is how we solve a square root method problem when it doesn't come out clean. Either the exact or approximate answer. We'll take a look at one more together, and then I'll have you try one to close the video out. I've got 3b squared plus 18 equals 6b squared plus 3. As normal, I'm going to start by putting a line down the equal sign. Now on this one, many students tend to always move the b squared term to the left-hand side. I wouldn't do that here. I would subtract 3b squared to move it to the right. But let's say that I didn't do that, and that I instead subtracted the 6b squared. Well, if that were the case, now I'm looking at 3 minus 6, which gives me negative 3b squared plus 18 equals 3. If my goal is to get b by itself, the next thing I'd want to do is subtract 18 from both sides. And once again, we're not quite ready to take the square root yet. We still have that negative 3, which in this case should be divided. And that takes me to b squared equals 5. We have succeeded in isolating the square root. At this stage, isolating the b squared. Got a step ahead of myself. Once we've got that, we can go ahead and take a square root. But once again, 5 is not a number that we can easily take the square root of. So I'm going to put both answers up here. The exact version of this would be that b is equal to the square root of 5 or the negative square root of 5. Or if the question asked you for approximate solutions, we would go to the calculator and figure out what the square root of 5 is. My calculator gives me 2.24. So my solutions would be b equals 2.24 or b equals negative 2.24. Okay, one final problem that I'd like you to try. Go ahead and pause this video to see if you can work through it yourself. And now let's take a look at the answer. We've got 14c squared minus 30 equals 12c squared plus 14. The best idea here would be to move that 12c squared to the left, giving me 2c squared minus 30 equals 14. I would add 30 to both sides. And divide by 2. Giving me c squared equals 22. This question does ask me for both the exact and approximate solutions. And based on that, 22, of course, not a number I can take the square root of. So for exact, I would have both the positive and negative square roots of 22. And for my approximates, I would need the square root of 22, which is 4.69. And negative 4.69. That concludes this video on solving with the square root method. Hopefully it was helpful to kind of give you a look at our second method for solving quadratic functions, quadratic equations, and we'll see more on the square root method in our next class. All right, thanks for watching.